All right, so I get the pleasure of ending up the morning talking about what are the different things that you can do as you go off to the exhibition floor this afternoon. You're looking at going back to your offices later this week and thinking about how can you prepare for a lot of these changes. My company comes from the big iron storage space. The CERN hydro accelerator we talked about earlier is running our systems. Those kinds of really big storage environments that used to really only be thought of for the elite few of the scientific community, research community, are becoming kind of commonplace in the enterprise. And what I think is really interesting as we tie up for the day is looking at, in the enterprise, what kind of changes should you be preparing for? What can you do today, not knowing exactly how you're going to want to adapt in the future for all these kinds of technologies that we're thinking about? So one of the main things I think that looking at is, it's not so much what is this disruptive technology. There's a lot in these conferences about disruptive technology. But how do we enable the user, the disruptive user who can think about what's that next application, what's that next program a developer can use? From a marketing perspective, how can I go to market that's going to really set a competitive edge aside for me and my enterprise? And I think the old Model T production line is a really great way of looking at this, that when Ford introduced mass production of the Model T car, it seemed obvious that a low-cost, highly reproducible product could displace the horse and buggy, change the way communities work. The changes implemented by putting a car in the hands of the average person was dramatic. However, it's really, really hard for enterprise, for individuals to think about what is that next technology to be predictive in what they're doing. And that's a lot of the net of what everyone's talking about is how can we be predictive? And in large part, that's users. It's putting the data that we're storing in the hands of the users. If you think about just the impact of putting a cell phone that has a high-resolution camera and video camera in it in the hands of pretty much everyone in the world, the real-time recording of live events, of the national kind of historic moments that nobody could predict were going to happen, and the kind of content that's being created there is pretty dramatic. But one of the big challenges we have in the enterprise is, even though the majority of data is now being created by individuals, over 80% of it is held in traditional big iron enterprise IT systems. So we all talk about how much data is out there and that IDC predicts there's going to be 20 zettabytes, which is such a huge number that the human brain has kind of a hard time even getting your mind around that. But thinking a little bit less about how much data is out there and how big can the storage system be and how can a file system scale to accommodate that, really where I think people are starting to change is thinking about, in this definition at the bottom here, of how can I extract value from the data? And that's really what we're thinking about now. You look at Hadoop clusters, you can store data extremely inexpensively for a long period of time, and Hadoop can extract value out of it. However, in the top 100 enterprises on the Fortune 500 list, very few of them actually have a production Hadoop environment right now. Many of them are POCing them, testing Hadoop. It's somewhere I think a lot of people will go in the future. So what can you and your organization do today to store your data properly that you can use it for analytics later? Make it accessible to those disruptive users who are coming out of college or coming out of the web community into the enterprise, and make it accessible for them to continue moving your businesses forward. So that idea of extracting value from your data, instead of just thinking about how I can store it, is a really, really big concept in how IT infrastructures are starting to change. And that's because we want to become predictive. I have a degree in biochemistry, and when I was in school, I would always put together a hypothesis for some kind of experiment that I had to prove so I could get done with the class and move on to the next experiment. I, in my mind, had to come up with my hypothesis and then walk through the scientific process to prove it. That's completely the opposite of what we're doing with big data with all this infrastructure now. Now we're looking at, it doesn't matter what the question is. I want to be able to use all my data to predict what questions I should have been asking, what kind of activities I should have been doing. My favorite example, and I'm sure some of you have heard this, is the way Walmart is using this kind of technology. Big retail shop that uses Hadoop, and they use predictive analytics around all of their retail data to decide where to put products in their stores. One of the things that they noticed was during hurricanes, they sell a lot of Pop-Tarts. They don't know why. They certainly didn't have, an analyst sitting there going, wonder when we sell Pop-Tarts during the year. All they know is during hurricanes or when there's one coming, they sell a lot of Pop-Tarts. Put Pop-Tarts next to high-margin items in the back of the store where you can pull people to the Pop-Tart aisle. Walmart does more sales when a hurricane is coming if they place their products that way. It's a really interesting way to look at using data to make it predictive is really the direction that the enterprise is going. Enterprises, and there's a lot of talk about big companies aren't nimble enough to really move forward and to take advantage of these kind of predictive trends. But what I really think with big companies is they have to make a shift. We used to store data for insurance, really, in case there was a compliance issue, in case there was an audit. Now, IT is becoming strategic, and whether you're putting the data in the public cloud, the private cloud, it's strategic to keep that data around if you can figure out how to extract value from it. So one of the biggest things you need to be able to do is store that data in a way that these analytics engines, that humans who are writing programs to access the data can actually read the data. Unlocking it from kind of the stronghold of the IT staff, the big iron infrastructure that takes a lot of administrative overhead to access the data, and storing it in a different way. So in this world where we have all this data that's being created, and where we historically really didn't think of the average company talking terabytes, hundreds of terabytes, petabytes, or even exabytes of data, now we're starting to see those trends of those really big researchers and the really big universities that have grappled with this problem for years moving into the enterprise. And so the shift in how we're thinking about data is what we really need to be thinking about. There's a new trend called deep storage out there, and it's just a different thought around how to store data. It's not sitting behind block storage device. It's not sitting behind a NAS storage device. It's this object tier that everyone has been talking about this morning. And it's the concept that you have these standard interfaces. The guys on the panel were talking about whether it's OpenStack or the Amazon services or the countless ones that are starting to come out there. But the goal of it really is anybody who can write an application to access a RESTful interface, some sort of web application, now can pull information out of that data. They don't need to know a lot about the file system structure. They don't need to know when the data was created or by who. They just need to be able to write an application that can ask the questions. So what we're seeing is this deep storage concept is changing the way you're thinking about storing your data, even if you don't know what your analytic environment is going to look like 2 or 3 years from now. Even if you don't know what your CIO or whoever's in that role is going to ask of you to produce from your data in the future, think about how you can start storing it now so you're ready for that. And as you go out and you're talking to your cloud vendors, the prospects for public and private cloud, these are the kinds of things you want to be thinking about asking them on their strategy. It's being able to break down those physical versus logical boundaries that really, if you're storing your data in a RESTful kind of format, in open file formats, where even if you don't know today what applications are going to be querying it, it really doesn't matter. It's just making sure it's stored in the appropriate way. So that's why you're starting to see the shift between object stores and file stores. If you think about file stores and how they were used in the past, they really wouldn't work for the long-term recovery of data, the long-term readability of data. A good example of this, I think, and kind of the kinds of problems we're grappling with, if any of you have been reading the news over the last year about the Voyager 1, it finally hit interstellar space after about 35 years with the golden record. The golden record was Jimmy Carter's effort to put a message out there into space, reaching out to see if is anyone out there, let's tell them about the Earth. You look at that was 35 years ago and 11 billion miles when it reached that interstellar space boundary. And the goal of this golden record is anyone could read it. Anyone being, extraterrestrial. It could be in billions of years. It could be in hundreds of years. We don't know. It will probably stop transmitting around about 2025, but the mission will continue for years and years and years after that. So what they were trying to accomplish with this golden record is kind of, on a very large scale, what we're trying to accomplish in IT. We are thinking about the next 10, 20, 30, 50 years of how we want to be able to access data. We don't know what applications are going to be reading it. We don't know what kind of information will be valuable from it, but we need to start to move to this kind of paradigm so we can accommodate that in the future. So the shift from the nested file system, where a user knows where their data is, and they know, I mean, when I create a PowerPoint, it's in my documents, my presentations, Cloud Connect 2013, Chicago. I know how to find my PowerPoint file. It'd probably be impossible for any of you to be able to find my PowerPoint file on my computer. Moving that kind of traditional methodology of how files are stored out of a nested file system that can be outgrown from just the logic of how it's stored to how much data it can store to the performance of how it can be stored is an important part to be starting to think about as you're storing your really large data sets for these kinds of uses. Object stores are flat versus hierarchical. The goal of it is you put similar data into a big bucket or an object, and that object is self-describing. And that self-describing nature is really important. When Alistar and I were talking earlier this year at a different conference, having that be self-describing so that whoever, the millions of people maybe who will access my data 5 years from now about a project, don't need to know really how I thought about it, but they can query the metadata around those objects. And then if those objects are written in an open file format that is also self-describing, so that you're looking at those open standards, whether it's on disk, tape, cloud, wherever you're storing your information, that you're using open file formats that are self-describing, that somebody down the road can read them without knowing anything about your infrastructure from day is really important. And this is where when I go out and talk to customers, which is what I do the majority of my time in my product management role, and I'm talking to the Fortune 500 enterprise guys, most of them are just looking at how can I store my data now and be sure I'm ready for these trends. And the two big keys are make sure it's self-describing, make sure you have metadata associated with your content, and make sure it's in some kind of open file format. If you're in proprietary formats and you aren't creating metadata, it's really hard to do later. Going back and rereading content to make metadata about it later is a huge effort. So create it now, even if you don't know what you need it for, so it's much easier to move into these infrastructures in the future. So that's the idea of one of the big technology shifts of object storage, that you have a unique metadata about each of the objects that is searchable. And it allows you to know a lot more about your content than you would have if it was just in a standard file system. If you look at a radiograph, for example, or an MRI, typically if you were storing in a file format, you'd know the patient, the doctor, the date, maybe what disease the person has. With an object store, you can create so much more searchable information about that then later, when the Watson computer is trying to predict cancer and looking at all this radiographical kind of information, it has a lot more fields of data it can ask questions about and crunch in those analytic engines. Having this metadata is absolutely critical to machines being able to do this kind of predictive analysis, though. The trick is implementing it, that you're capturing the metadata as the data is being created. You can't forget, though, that all the things traditional IT has been tasked with, data protection, easy expansion, cost-effective natures, user access as well as application access, we can't just forget that. Enterprises have to continue to do the business that they do today. But in looking at as you deploy these environments, as you look at these deep storage infrastructures that are becoming increasingly common, they have all those traditional things built into them for data protection and enterprise compliance, those types of things. But they're also expanding to meet these future predictive needs of the data sets. So what this is really enabling is the implementation of new infrastructures that make data accessible to the disruptive thinkers in your organizations. That all those people creating the data actually have access to write applications to do interesting things with the data. And it doesn't have to be under enterprise IT control anymore, which really enables those disruptive users to move your enterprise forward to make more money and move into the future. With that,